The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today eventually we're going to go on to section 10.2 part 2, but before we do that, we have a question from 10.2 part 1, and that is number, wait a second, hang on. Yeah, that's number 16. Okay. All right, let's see here. So the problem says solve the equation, and it's negative x squared plus 10x equals 22. Well, the first thing I notice is my x squared has a -1 coefficient, and I want it to be positive. So I've got a couple of options. I could subtract 22 from both sides of the equation, and then multiply both sides by -1 to turn that negative x squared into a positive x squared. Or I could just move the two terms on the left side of the equation to the right side of the equation, which would make it positive x squared. Either way is two moves. I'm going to move everything to the right. So I'm going to add x squared and subtract 10x. Add x squared and subtract 10x. So now I've got 0 equals x squared minus 10x plus 22. So now it's in standard form, and A is 1, B is -10, and C is positive 22. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I want to point out that the -10 inside the radical, it has parentheses around it. I'm squaring -10. It's not -10 squared, it's -10 squared, right? So we get x equals 10 plus or minus the square root of 100 minus 88 all over 2. 4 times 1 times 22 is 88, and it's minus x equals 10 plus or minus the square root of 12 all over 2. Okay, now the square root of 12 is the square root of 4 times 3, which is 2 square roots of 3. So x equals 10 plus or minus 2 square roots of 3 all over 2. Now, when you have a situation like this, and all three of those terms have a common factor, in this case, they're all even, so a 2, I can reduce this thing down, okay? So here's what I'm going to do. I'm going to factor a 2 out of the top, okay? Any questions about what I did there? So now I can reduce those down. So x is 5 plus or minus the square root of 3. Now, this particular problem in WebAssign was a multiple choice. So in this case, they do use the plus or minus notation, as you can see here. So this problem, or this item down here, would be the correct answer, 5 plus or minus the square root of 3. Okay. Moving on, unless there's any other questions. Okay. So now we're going to look at application problems from section 10.2. And this first one, it says, crosswalks. Refer to the illustration below, which of course you can't see, but I'm going to draw it. So let's see here. We've got this. Okay. This is Nordstrom. And this is Best Buy. And this is Main Street, and this is First Avenue. Okay, now there are crosswalks going, let's see here, here, and here, and here, and here, and there's also one that is the diagonal. All right, it says, refer to the illustration below. Instead of using the Main Street and First Avenue crosswalks to get from Nordstrom's to Best Buy, so instead of using the Main Street and the First Avenue crosswalks to get from Nordstrom's to Best Buy, a shopper uses the diagonal crosswalk to walk 97 feet directly from one corner to the other. Okay, so they're saying that this diagonal is 97 feet. If the length of the Main Street crosswalk, so that's this one, is 7 feet longer than the First Avenue crosswalk, that one, so the Main Street crosswalk is longer than the First Avenue crosswalk. So if we call this one X, this is going to be, it says 7 feet longer. Okay. How much walking does the shopper save by using the diagonal crosswalk? All right. So what this problem boils down to is a right triangle. Oops, let's draw the picture correctly, at least. So this side is longer than this side, it says. What do we know? We know that this is 97 feet, this is X feet, and this is X plus 7 feet. Okay? Any questions about where I came up with that triangle? Now, recall the Pythagorean theorem that says a squared plus b squared equals c squared, where c is always the hypotenuse. In this case, c is the 97. Let's see, we'll call this a. Let's use the correct, we're using small letters. So this is a and this is b. Okay, so from that we get the following: x squared plus the quantity x plus 7 squared equals 97 squared. So x squared plus x plus 7 times x plus 7 equals, let's see here, 97 squared. 97 squared is 9,409. I need to warn you, the problems in this section have very large numbers, so you'll most likely be using a calculator. So then we get x squared plus x squared plus 7x plus 7x plus 49 equals 9,409. Combining like terms, 2x squared plus 14x plus 49 equals 9,409. I'm going to subtract 9,409 from both sides. So I get 2x squared plus 14x minus, let's see, if we take 49 minus 9,409, we get 9,360, and that equals 0. Okay, let's see here. I'm gonna double check my work here, see if I've made any mistakes that are obvious. Now, I have a quadratic equation in standard form. I see that all the coefficients are even. So if I wanted, I could divide everybody by 2 or factor out of 2 and divide both sides by that to make my numbers smaller. I don't have to, but I'm going to do that anyway. So x squared plus 7x minus, let's see here, 9,360 divided by 2 is 4,680, and that equals 0. All right. I'm going to take this and write it on the next page before I start using the quadratic formula. So I've got x squared plus 7x minus 4,680. 4,680 equals 0. Does anybody still need to write anything from this page, or can I go on?
You're good.
Okay, so A is 1, B is 7, C is negative 4680. X equals negative B plus or minus the square root of B squared minus 4A C all over 2A. X equals negative 7 plus or minus the square root of 49. And then I've got minus 4 times 1, which would be negative 4. Negative 4 times negative 4680. Oops, 4680. 4680. And I get plus 18,720 all over 2. X equals negative 7 plus or minus the square root of, if we take 49 plus 18,720, we get 18,769 all over 2. If I take the square root of 18,769, so let's see here. I get 137, and that's all over 2. So then I've got X equals negative 7 plus 137 over 2, which is 130 over 2, which is 65. X equals negative 7 minus 137 over 2, which is negative 144 over 2, which is negative 72. So X equals negative 72 and 65. Now, the problem with this is X represents a distance. So X can't be negative. Okay, so if X is 65, let's see here. This is 65 feet. 65 plus 7 would be what? 72 feet. But we're not done. The question said, how much walking does the shopper save by using the diagonal crosswalk? Okay, if the shopper walks here and here, that's 72 plus 65, which is 137. If the shopper walks here, that's 97. The difference is 40 feet. So the shopper saves 40 feet of walking by using the diagonal versus the two sides. Of course, you're all sitting there going, yeah, but if I hadn't spent 10 minutes calculating this problem, I'd be there going the long way, so who cares? Well, okay, that's probably a good argument, but you'll just never know. Okay, any questions about this problem? All right, new example. This says the hypotenuse of a right triangle, so that's the longest side, is 2.5 units long. The longer leg is 1.7 units longer than the shorter leg. Find the lengths of the legs of the triangle. Okay. The hypotenuse is 2.5 units. The longer leg is 1.7 units longer than the shorter leg. So we'll call the shorter leg X and the longer leg is X plus 1.7. Okay, find the lengths of the legs of the triangle. So this is basically just like the last problem. Okay, we're going to approach it the same way. Let's see, we'll call this A and this B. Again, the hypotenuse has to be C. So A squared plus B squared equals C squared. X squared plus X plus 1.7 squared equals 2.5 squared. X squared plus X plus 1.7 times X plus 1.7 equals 6.25. 2.5 times 2.5, 6.25. Foiling X squared plus X squared plus 1.7x plus 1.7x plus 1.7 times 1.7, which I think is 2.89. Let me double check that. 1.7 squared Yes, 2.89 equals 6.25. Combining like terms, 2x squared. 1.7 plus 1.7 is 3.4. X plus 2.89 equals 6.25. We'll subtract 6.25 from both sides of the equation. 2x squared plus 3.4x. And then let's see, we've got 2.89 minus 6.25, which is minus 3.36 equals 0. Well, let's get rid of the decimals, okay? So we're going to multiply everything by 100. So I'm going to get 200x squared plus 340x minus 336 equals 0. Now I've gotten rid of the decimals, but I also see that this thing has huge numbers. And again, you know, it's kind of up to you how much time you want to spend making things nicer. I can see that a 4 is common to all of them. So I'll divide everybody by 4. So I get 50x squared plus, let's see here, 340 divided by 4 plus 85x minus, and then I've got 336 divided by 4 minus 84 equals 0. Okay, so I've got my second degree or quadratic equation in standard form. I've gotten rid of the decimals. I've reduced it down. I'm going to take this and go to the next page. Before I do that, anybody still writing stuff down from this page? Nope. Okay, so I'm going to recopy that. 50x squared plus 85x minus 84 equals 0. I'm going to double check my calculations just to make sure. And let's see, 1.7 squared. Da, 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 da. Okay, that looks good. That looks good. Okay, I think we're okay. All right. A is 50. B is 85. And C is negative 84. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 85 plus or minus the square root of, let's see here, 85. Oops, 85 squared is 7,225. And then we've got minus 4 times 50, which would be minus 200 times negative 84. And I get plus 16,800. I told you the numbers in this section were big. 2 times 50 is 100. X equals negative 85 plus or minus the square root of, let's see, 1680 plus 7,225 is 24,025 all over 100. Let's hope that's a perfect square. X equals negative 85 plus or minus, let's see, the square root of 24025. That is 155. Nice. All over 100. So I've got X equals negative 85 plus 155 over 100, which would be what, 70 over 100 or 7/10. Let's see here. As a decimal, that would be 0.7, and that's units. Why did they go? I looked to see if they wrote the answer as a decimal, and they did. If you'll recall, our original problem had decimals in it. 7/10 is still a correct answer, but they went with a decimal. Okay, or x equals negative 85 minus 155 over 100. Let's see. That would be what? Negative 240 over 100, or negative 2.4 units. But once again, x is a distance, so x can't be negative, okay? So this is going to be what? 0.7 units. And then 0.7 plus 1.7 would be 2.4 units. So the longer leg, 2.4 units, the shorter leg, 0.7 units. Any questions about that problem? All right. Here comes one with a rectangle. It says IMAX screens. The largest permanent movie screen, at least as of the publishing of this book, is in the Panasonic IMAX Theater in Darling Harbour, Sydney, Australia. The rectangular screen has an area. Okay, so we've got a rectangular screen, and the area is 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. So if this is the length, and this is the width, it says it's 20 feet longer than it is wide. If we call the width x and the length x plus 20, right? 20 feet longer. Okay, now we're dealing with a rectangle. Area equals length times width. So the area, 11,349, equals x plus 20 times x. 11,349 equals x squared plus 20x. We'll subtract 11,349 from both sides, and we get x squared plus 20x. Here, let's leave it on the correct side. It doesn't matter though. We'll get 0 equals x squared plus 20x minus 11,349. A mistake that students will make is they won't bother to put the quadratic equation or the second degree equation in standard form before they decide what A, B, and C is. And you got to be careful because A, B, and C may have a different sign once you put them in the right place. So always put them in standard form, either 0 equals it or it equals 0. A equals 1, B equals 20, C equals negative 11,349. Here we go. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 20 plus or minus 20 squared is 400. Minus 4 times 1 would be minus 4. So then we've got minus 4 or negative 4 times negative 11,349. So that's going to be plus 45,396 all over 2. And 45,396 plus 400 is 45,796 all over 2. Let's see if that's a perfect square. So that is 214 all over 2. So x equals negative 20 plus 214 over 2. And let's see. That's going to be 194 over 2, which is 97. Negative 20 minus 214 over 2. So negative 20 minus 214 is negative 234. Divided by 2 is negative 117. And again, we're going to eliminate that answer because the distance can't be negative. Excuse me. Okay. So we've got the width is 97 feet. The length is 97 plus 20, which would be 117 feet. Okay. Let's see here. The only thing that bothers me about this problem is that if it's in Australia, they use the metric system there. So it seems like the problem should be done in meters, but oh well, whatever. Okay. All right. Let's see how we're doing for time. Lots of time. Excellent. All right. This says parks. Central Park is one of New York's best known landmarks. Rectangular in shape, its perimeter numerically exceeds its area by 4.5. Find the dimensions of Central Park if we know that its width is less than 1 mile. Now, what do they mean by numerically? Well, the perimeter would be in units of, let's see here, miles, whereas the area would be in units of square miles. So they're saying basically ignore the units and just look at the numbers numerically. Okay. Its length is 5 times its width. So if this is the length and this is the width, if this is x, this would be 5x, okay? The length is 5 times the width. Okay. When measured in miles, its perimeter, let's see, the perimeter would be 2 times the length plus 2 times the width. So that would be P is 2 times 5x plus 2 times x, which is 10x plus 2x, which is 12x, okay? So that's one important piece of information. The perimeter is 12x, exceeds its area. Let's find the area. Area would be length times width. So that would be 5x times x, or 5x squared. So there's another valuable piece of information. It says when measured in miles, its perimeter exceeds its area by 4.75. So the perimeter exceeds the area, okay? So the perimeter is greater than the area. How much greater? 4.75. So our equation would be 12x equals 5x squared plus 4.75. Again, the perimeter is this much more than the area. You okay with that? Any questions there? All right. I'm going to subtract 12x from both sides, and I come up with the following. 0 equals 5x squared minus 12x plus 4.75. Okay. Once again, we've got a decimal. Let's go ahead and get rid of it. So we'll multiply both sides by 100. We get 0 equals 500x squared minus 1200x plus 475. I believe I could divide everything by 25, so I will. So 0 equals, let's see, 500. A second here. I'm roasting. It's finally getting warm in this basement. All right. So we've got what, 500 divided by 25, which is going to be, so 0 equals 20x squared minus, we've got 1200 divided by 25 minus 48x plus 475 divided by 25, 19. Okay, a little better. Okay, let's see here. 12x, x squared, that, subtract, looks good there. 5 by 100, 25. All right, so I'm going to take that and write it on the next page. 0 equals 20x squared minus 48x plus 19. And we're ready to use the quadratic formula. A is 20, B is negative 48, C is 19, X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative times negative is positive 48 plus or minus the square root of negative 48 times negative 48. Helps if you get the calculator turned on first. 2,304 minus 4 times 20. So minus 4 times 20, which is negative 80 times 19. So minus 1520 all over 40. X equals 48 plus or minus the square root of, let's see here, we've got 2304 minus 1520 is 784. The square root of 784 is 28 all over 40. So X equals 48 plus 28 over 40, which is what, 76 over 40. And let's see here, 76 divided by 40 is 1.9. X equals 48 minus 28 over 40, which is 20 over 40, which is 0.5. Now, the units are miles. These are both positive values, so we don't have a negative one to throw out because of a distance. However, let me remind you, in the original problem, it said, if I can find the original problem, find the dimensions of Central Park if we know that its width is less than 1 mile. So that means this can't be the 1.9 miles. That's the only reason we know that, okay? So this is what, 0.5, and this would be 2.5, and this is miles, and this is miles. This is lovely writing here. Okay, so the dimensions are 2.5 miles by half a mile, approximately. All righty. Let's take a look at another picture. Literally, this says, the matting around a picture has a uniform width. How wide is the matting if its area equals the area of the picture? Round to the nearest hundredth of an inch. Okay, so we've got this picture frame, okay? And inside of it, there's a picture. And let's see, what do we have here? We have some water and some trees. And there's a nice, lovely boat out there. And I'm not an artist, as you can tell. All right, what do we know? We know that the matting around it is of uniform width. We also are told that this distance from here to here is 5 inches. And this distance from here to here is 4 inches. So the picture, the dimensions of the actual picture, not including the frame, is 5 inches by 4 inches, okay? We also know that this matting around the picture is of uniform width. So why don't we call this X? We'll call that X, okay? Uniform width all the way around the picture. All right. It says the matting around the picture has a uniform width. How wide is the matting? So we're trying to find X. If its area equals the perimeter of the picture, round to the nearest hundredth of an inch. Okay. So what do we know? The area of the picture would be 4 times 5, which is 20 square inches. Okay. We're told that the area of the matting is equal to the area of the picture. So we'll say this is area of the picture, area of the matting is also 20 square inches. So total area is what? 20 plus 20, 40 square inches. Okay, so the total area is 40 square inches. Now, consider this. Let's take a look at that situation. From here to here is 5 inches, right? But isn't this x and this x? So that total would be 2x plus 5. Everybody okay with that? Where I got that? Any questions there? All right, let's take a look at this. Well, from here to here is 4 inches, and this is an x, and this is an x. So this would be 2x plus 4. Everybody okay with where I got those outer dimensions? So that means that 2x plus 5, the length times the 2x plus 4 width of the outside is equal to the total area of the whole thing. Okay, everybody? All right, going on. 4x squared plus 8x plus 10x plus 20 equals 40. Combining like terms, 4x squared plus 18x plus 20 equals 40. Subtract 40 from both sides. 4x squared plus 18x minus 20 equals 0. All the coefficients are even. Let's divide by 2. 2x squared plus 9x minus 10 equals 0. Okay. Let's take that and go to the next page. 2x squared plus 9x, 2x squared plus 9x minus 10 equals 0. Okay. A is 2, B is 9, C is negative 10. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 9 plus or minus the square root of 81 plus 80, right? Negative 4 times 2 is negative 8 times negative 10 is positive 80 all over 4. X equals negative 9 plus or minus the square root of 161 all over 4. Now, I'll just bet you that 161 is not a perfect square, and here's why I know. Let me read the directions again. The matting around the picture has a uniform width. How wide is the matting if its area equals the area of the picture? Round to the nearest hundredth of an inch. Aha! They're telling us to round. That tends to mean that our answer is not going to come out nicely. So, but just in case, let's take the square root of 161, just to make sure. Okay, second, square root of 161. Yeah, it's like 12.6885. Anyway, okay. So let's find that. And that. So parentheses, negative 9 plus the square root of 161, close up the parentheses, close up the whole thing divided by 4, and I get 0.922144, etc. It's said to the nearest hundredth, so that's 0.92, right? Because this is the hundredth place and the 2 would round down in the thousandth column. So we've got that possibility. And then the minus, let's see here. I get negative 5.422, so negative 5.42. Okay, but once again, we're dealing with an x that is a distance or a length. So in this case, we throw out the negative. And this is going to be what? So x is 0.92 inches. And the question said, how wide is the matting? So to the nearest hundredth, 0.92 inches. So almost an inch, right? Okay. Let's see here. Oh, we got time for another one. This says dimensions of rectangle. A rectangle is 4 feet longer than it is wide. The area is 20 square feet. Okay. Find its dimensions to the nearest tenth of a foot. So this is going to be another one that's not going to come out exact. So 20 equals x times x plus 4. Area equals width times length, or length times width. 20 equals x squared plus 4x. We'll subtract 20 from both sides. 0 equals x squared plus 4x minus 20. So a is 1, b is 4, c is negative 20, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 4 plus or minus the square root of 16 plus 80 all over 2. X equals negative 4 plus or minus the square root of 96 all over 2. And I'll just bet you that 96 is not a perfect square. Let's see here. No, it's not. Okay. So x equals negative 4 plus the square root of 96 all over 2. X equals negative 4 minus the square root of 96 all over 2. Let's see here. Parentheses, negative 4 plus the square root of 96. Close up the square root, close up the whole thing divided by 2. 2.89897, etc. And it said to the nearest tenth of a foot. So the 8 would be in the 10th spot, the 100th spot, the 9 would round up, so 2.9 feet. Now, you might be thinking, Mr. Mayo, I can see that a negative minus something else divided by 2 is going to be negative, and a negative answer isn't going to work. So in this case, do I even really need to calculate it? No. If you can see ahead that you're going to get a negative answer that can't be a distance, you don't need to calculate it. So this is what, 2.9 feet. And this, let's see, this would be what? 2.9 plus 4, 6.9 feet, approximately. All righty, any questions about that problem? So, how many of you could write the quadratic formula from memory on a piece of paper right now?
Ding, ding, ding.
Excellent. You win some lovely used calculator batteries. Anyway, work on getting it memorized, okay? All right, that's all I have for today. I will be back at 1:15 this afternoon. So for tonight, you're going to be doing, what is it, 10.2 part 2.